Welcome to a new lesson, solving problems involving objects. Let's take a look. Determine the volume of this composite object to the nearest tenth of a cubic meter. Let's first talk about what a composite object is. A composite object is an object composed of more than one, different shapes. For example, the object to your right is composed of a pyramid, rectangular pyramid, and a rectangular prism. Because of these two different shapes, we have to consider two different volume formulas. So let's take a look at the formula for the rectangular prism first. Volume for a rectangular prism or a rectangle in 3 dimensions is length times width times height. So the volume of the rectangular prism is 6.7 times 2.9 times 2.9 again. And this volume to the nearest cubic meter is equivalent to, well, let's not worry about the cubic meter at this time. We're going to once we combine the two volumes of the rectangular prism and the pyramid, we will round off to the nearest cubic meter. So right now, our rectangle, which is right here, is 56.347 meters cubed. 3 dimensions, that means meters cubed has to be used as a unit. Now we're going to be calculating the volume of this rectangular pyramid. Recall that the volume of the rectangular pyramid is a third area of the base, times its height. And in this case, it is, because it's a rectangle, it is length times width, in this case times height. Notice that these lengths and widths are different for rectangular prism than they are, or actually they're not different, they're actually the same, because they share the same length and the same width with the prism as you see below. So let's solve this problem. So volume is 1/3, 6.7 times 2.9 and times the height. Now the height is not 2.9, but it's actually 2.1. It's perpendicular straight to the tip or the apex of the pyramid, which is 2.1. So when we multiply all of these together, we will get the value of 13.601. However, the question is asked for a composite object, and the composite object is equivalent to the addition of these two numbers. So volume, therefore, the total volume, or you could say V total, that's fine too, is equivalent to the addition of 56.347 with 13.601, and the answer to the nearest cubic meter is, nearest tenth of a cubic meter is 69.9 meters cubed, and that's your answer. Let's take a look at another example. Determine the surface area of this composite object to nearest square foot. First, we have to understand what is the surface area of this object. First of all, we have a hemisphere, but that hemisphere does not include the sphere here, the circle right there. It does not include. We also have a cylinder, and that cylinder does not include, again, the circle up top. Does not include the circle up top. That's not included. But there's one circle at the base So there are two things to consider. There are two shapes, a sphere and a cylinder. So let's talk about the cylinder and the sphere together. The surface area is for a sphere 4 pi r squared. However, for a hemisphere is half of that. We also have the circle at the bottom of the cylinder, so that is plus pi r squared. That is the circle. And I'm just going to draw this right below it, so you see that that's just a circle of this cylinder. And I'm just going to draw this nice little half hemisphere. And what's left is this lateral face, the lateral face of the cylinder. Now the lateral face of a cylinder has a specific formula. It is the perimeter of the cylinder all around, which is 2 pi r times the height of the cylinder. So I'm just going to redraw it for you. I'm going to add this, and it's this area right there. So we're going to add these three different areas together to find our answer. We just have to plug in the value of the radius into our equations. The radius is 2 feet, and pi 2 squared plus 2 pi times 2, and the height is 4. And our surface area to nearest square foot turns out to be approximately 88 feet squared. And that's our answer. Again, in this question, we added the half a hemisphere, a hemisphere, surface area, a circle, and a lateral face of the cylinder. Let's take a look at the last example. A cabinet à sucre is a composite object, that means an object composed of more than two different shapes, formed by a rectangular prism with a right triangular prism as its roof. Determine the surface area of the cabinet à sucre in square yards. In this case, it is a good idea for us to unravel this shape. And this is what it would look like if we unravel it. Now, let's talk about this part. This is the base, so there you go. The lateral face right here, and the back lateral face. The triangle roof, there are two. The side walls, there's one and there's two. And the roof sides. What's one? And there's another one. So we are dealing with 1, 2, 3, 4, 5, 6, 7 rectangles and 2 triangles. So we're going to label the sides that we know. That's 5 yards. We also know that this is 3 yards. And we also know that this is 2 yards. These 2 yards are right there. What we do not know, we also know that this is 2 yards as well. And I'm just going to use this as 2 yards, and this is also as 2 yards, the green. What we do not know is these dimensions right here, this side dimension, which is this dimension of the roof. So that is the first thing we have to find out. We have to find this this dimension in order to find the rectangles on the sides. So notice that there's a triangle right here, and I'm just going to make it a little bit bigger on the side for you to see. It's a right angle triangle. Pythagoras. We use Pythagoras, which is just 2 yards, to find this unknown dimension. This is the hypotenuse, which is c, the longest c side. The bottom is, if you look at the 3 yards, is half of 3 yards, which is 1.5. So we're going to use this Pythagoras to find the missing sides of the rectangle side that we're looking for the roof. So c squared is equal to a squared plus b squared, and we'll just plug it in. C squared is equal to 2 squared plus 1.5 squared. Therefore, c squared is equal to, if we combine this, we get 6.25. Then we have to square root both sides, cancel out the square. Therefore, we get c is equivalent to 2.5 yards. So now we have the dimension for the missing side, which is 2.5 yards. Forgive me for writing in red. Now we have dimensions of all the shapes. I'm going to also label it 2.5 yards right there. Now we're going to use all these dimensions to find the surface area of all of these shapes. And then we're going to add them. So the first shape we're going to be looking at is the base. So surface area. So base is length times width, which is 3 times 5. That's 15 yards squared. So we have the base. So that's done. Now we have 2 rectangles, the side walls, and it's 5 times 2. So sides. And since there are 2 of them, I'm going to multiply by 2 first, and multiply by the other dimensions, which is 2 times 5. And that's 10 yards squared. So the sides are done. Now we're going to also multiply, I'll multiply by adding 2 more sides to the triangle. That's the front and the back face, which is right here, the front and the back face. And the dimensions are 2 by 3. And there are 2 of them. So there are different sides. There's 2 of them, and the dimensions are 2 yards by 3 yards, which is 2 times 4 is 12 yards squared. So that's the sides are done. There are also, we're going to do the next part, which is the roof. And we found out that the roof has 2 sides. That's the slanted heights, as you notice right here in red. There are 2 of them, and their dimensions are 2.5 by 5, which turns out to be 25 yards squared. I'm not putting the yards because I have no space. I'm just going to kind of draw a line here to make sure if there's, you could see a little bit better. And the last part is left is the triangle. Okay, little check marks. The last part is the triangle. And notice the triangle, I'll draw it to you right here. This is the triangle. It's base times height divided by 2. So the triangles, and there are 2 of them. I'm going to go just try. There are 2 of them. So we'll multiply 2 by a half times the height of the triangle, which is 2, and the base of the triangle, which is 3. So our triangles areas are 6 yards squared. So we covered all of the possible, there you go. We covered all the possible composite shapes, and then for the entire surface area we need to add them. So we're going to add all of these values together, 10, 15, 12, 25, and 6 together. Once we add them, total surface area, or total SA, it should be equivalent to, so the answer is 68 yards. You have to be careful in this example, of course squared, that you do not make a mistake. So you should always be double checking. And I've made a mistake, because if you look at the sides, it's 2 times 2 times 5. Well, that's not 10. It's actually 20. So your overall answer is not going to be 68, but 10 more, which is 78 yards squared. And here is your answer. One of the questions can arise in your test is that, do I include the base in this area? And it is really unclear based on this problem, is that do I include the base of this little cabinet sucre in the calculation of the surface area? If you're unsure, you could always ask your teachers to ask, do I include the base for a surface area? And they would clarify for you.